Okay, well, so this is, we're going to get into the panel discussion. This first panel discussion is focused on the contribution of earth observation into agricultural markets and helping to reduce volatility and support stable markets. And I think the G20 Ministers of Agriculture made it clear when they launched the 2011 Action Plan on Food Price Volatility in Agriculture that satellite data have a key role to play in enhancing information to support agricultural commodity markets. And with that, I'd like to have the honor to introduce our first speaker, Dr. Joe Glauber. He's a senior research fellow at the International Food Policy Research Institute and the visiting scholar at the American Enterprise Institute in Washington, D.C. But prior to joining IFPRI, Dr. Glauber spent over 30 years at the U.S. Department of Agriculture, including as its chief economist from 2008 through 2014, where he was responsible for the department's agricultural forecast and projections and oversaw climate, energy, and regulatory issues.
Great, thanks. Good. Thanks and welcome. I really want to thank Inbal for the invitation. We've been working a long time together. As has been mentioned several times, this effort stems out of the G20 effort that when markets were highly volatile in 2010, 2011, and again, price spikes following price spikes that had been there in 2007, 2008, the world was concerned about the level of information available to markets, the level of information available to countries. One of the big things was to try to avoid some of the mistakes that were made in 2010, 2011, with countries putting on export bans and all sorts of things, thinking that they were helping stabilize prices, and while they may have been stabilizing prices in their own markets, they were destabilizing prices elsewhere. And so it was thought that having better information would really help matters. And it was with that the G20 launched AMIS, the Agricultural Market Information System, and I think we'll hear from someone from that soon. But the other thing was GEOGLAM. And as Inbal mentioned, at the time I was with the U.S. government, was the U.S. lead at the G20 technical meetings at that time, or the Sherpa, or the sub-Sherpa, YACs, I think we would call it. But the important thing was trying to, for me, I was interested because we were coordinating a lot of the supply and demand estimates at the time. And I think so this whole issue of what information provides to the market and how it helps consumers, producers, and others make decisions about allocating commodities and allocating inventory and allocating food and other things to keep prices less volatile and to improve the efficient flow of commodities. Information is very, very important. And that's not news. I mean, everyone knows anyone who's familiar with this business knows that when USDA puts out a report, the markets, the futures markets and others typically move, particularly during times where a lot of uncertainty is being resolved. So during a production season, for example, when yield forecasts come out, you can see the markets are weighting that, they're anticipating that. There's a whole industry of market analysts who put out forecasts of their own about what USDA is going to forecast. So I think that it's easy to see why information is important. And I think a lot of the studies that have been done show that information, while you would think that with technologies and others that maybe these reports are less important or other things, but indeed, I think a lot of the reports show that they are, or a lot of the studies that have been done show that these reports are even more important now, or at least have an even greater effect in terms of futures market activity and other things. So part of the project I'm working on with Jarvis, by the way, is trying to value this very thing. And I have a slide deck, but I'm not going to go through it very much. What I want to do here is just forecast focus on one thing and kind of walk you through how information is revealed and what the value of that is in one sense. So this is USDA begins forecasting in May of each year. They're forecasting for production that's going to occur for the most part in the fall of that year. So they do winter planted crops, but also spring planted crops, and then they'll be harvesting the fall that year, and then they're carrying through forecasts on that marketing year all the way to the next year. But not only are they doing it for Northern Hemisphere, they're also doing it for Southern Hemisphere. So these production forecasts can be as far as 24 months out in terms of what they're actually making forecasts on. And here I'm going to focus on one variable, ending stocks, which are typically an important indicator of a relative tightness in a market, particularly when it's used, when it's looked at vis-a-vis consumption or other things. But here I just want to show, and you don't need to be a statistician to know what these, to understand these, the measures, but it's just to say that early on, no surprise, forecasts, there's a lot of error about that forecast. So all I've done here is looked at the final estimate compared to what the forecast was 19 months out. That is when we make our first forecast in May, and there's a lot of volatility there. I think that's measured in metric tons. It doesn't really matter. It's just to say that a lot can happen over the next 18 months. And you can see that it's not just a straight line. So what that means is that uncertainty gets resolved in sort of discrete periods. That there's some periods that are more important than others. This water is going to go everywhere. There's a shelf down here. I can just bump out with my foot now. So it gets resolved over time. But here you can see that, so now what I've layered on here, and I'll try to, you can see I'm blocking, you've got a crowd here, and so your speaker will always be blocking somebody's view of the screen. You can see here that this just shows the same chart that Inbal showed earlier, that is over the period from August to about November, December, where NASA is doing estimates of the yields, crop yields for soybeans. You can see that a lot is getting resolved. That's that yellow line there. And then even once the January number comes out, they can be revised later, a year later, up to a year later, where we might get another estimate and then finally some resolution there. But you see there's still a lot of uncertainty in that market. And a lot of uncertainty about demand, a lot of uncertainty about exports. So for example, Brazil, which is a major exporter of soybeans and competitor of the U.S. In many markets, you can see that they have a lot of their uncertainty because it's in the southern hemisphere is getting resolved somewhat later, and so you're looking at planting times in the fall with yields being resolved in the early part of the next year, and so a lot of their uncertainty again you can see gets resolved, and over that period so does a lot of the uncertainty about ending stocks. Other things, if you look at other commodities, again, depending on where they are in the world, you can see some with a lot of uncertainty. If you look at a country like Australia, or you look at a country like Russia, where we have a lot of volatility in yields because of the weather, they may start very, very high, but again, get resolved at various points during time. And similar with maize, and I don't need to go through this much. The point I wanted to make is that where Earth observation can really help is, as Inbal said, is if one can think about reducing forecast error either by an earlier forecast, which in some areas of the world where we have less information and don't have maybe the sort of on-the-ground statistical surveying and other sorts of things, Earth observation data obviously give us a very quick, or can give us very real-time estimates of yields and area and other sorts of things earlier than we might get otherwise. And then the other thing is forecast error, and whether or not the forecast itself, the error, we can resolve that by greater resolution and other sorts of things. And so I think, to a degree, these are questions that we're trying to answer, at least my research partner and I are looking at, well, what are the costs of improving information and relative to what the benefits are. And so that's a lot of what we're doing. And I think I'll just close with saying, obviously, the other thing, and I think we have a panel on this later, is what the value of early season forecasts are for things like food security. Does that mean that that identifying a drought early, does that help move, help the donor community move assistance to those areas earlier? And so those sorts of things, obviously, information really matters. And information has a real value. And I think part of the thing we're trying to do here is at least put that in the context of costs and other things. So with that, let me stop and I'll turn it over to the next person and get out of the spotlight.
Thank you very much. Joe, our next speaker is Professor Matt Hansen. He's a professor at University of Maryland Department of Geographical Sciences and a leading remote sensing scientist with a research specialization in large area land cover and land use change mapping.
Thanks, Inbal. I'm going to talk more about the Earth observation side and where we might be going. Emphasize really we're in this golden age of monitoring, particularly the temporal domain. That's really what agricultural monitoring is all about, is getting the time step fine enough that we can really track crop development and production. And the expertise in this room, whether it's for yield or area or condition forecasting, is world class. And my example is going to be for crop type and area. The rationale, one example recently is China statistics, official statistics being revised. And if you look at the graphs over time, it looks like we're getting more uncertain information out of China for very important commodity crops like corn and soybean. And you would think this is impossible given our improved data streams and methods. So our focus is, how do we create consistent global monitoring of commodity crops, given the Earth observations that are consistent over the entire planet's surface? And can we develop methods that are consistent through time and across space? And I think we should look more towards a convergence of evidence, whether it's a national reporting scheme or a third-party NGO or a private company. We shouldn't have results like this. So that's kind of a point of emphasis, even for conceptually simple themes such as area. Our methods are really about using the satellite as an indicator product. I think another challenge for Earth observation is not to be too disruptive to traditional methods. So our approach is based on field sampling using probability-based methods, which is a traditional construct for statistical estimates. So the satellite products that we make, they're not pixel counts. We use the satellite to target our theme of interest, for example, soybean or corn or wheat, and then we go to the field. The satellite gives you a very robust approach, a method for, a reference for finding homogeneous populations such as soybean cultivated area. And then in the end, we make a map, the best map we can. And of course, maps have a whole other use case in terms of looking at changes in landscapes and rotation and other land use practices. But the statistics are really sample-based, and that fits kind of standard approaches. What's really fun about I make the joke, we do a lot of forest mapping as well, and I joke that when the forest is gone, we got to be experts in agricultural monitoring. So I spread the risk by focusing on agriculture. But agriculture is much tougher. I mean, you talk about a human signal, the different crop types, the cultivars, the irrigated, non-irrigated, rotations. It's awesome to try and characterize even a simple theme such as soybean at a continental scale. So we're dealing with different signals, and we're trying to tease out just one particular commodity. And this graph kind of represents that. We can train algorithms and run them at scale. So we can run North America, we can run South America. We try to get a kind of continental scale season and kind of theological growth period. And from that history, if we build up the time series, we can know where the dominant soy or corn or wheat cultivation areas are and build a stratification around that. So we can say, where's the core, densely planted areas versus the lower density areas, and then throw a sample within these strata, and then go to the field. So instead of having a fixed sampling frame, it's more dynamic. This is appropriate for South America. In our estimate, the last 3 years, Brazil's averaged 20,000 square kilometers more soybean every year. So places change. Africa, extensification is huge, and the projections for population growth and smallholder ag are big. So the landscape changes dramatically in a lot of parts of the globe. And the satellite effectively chases that signal and allows us to keep up with the land changes. So when we look at these samples, we redo this every year. And we can go down and go to the field and by construction have a probability-based, unbiased estimate of soy cultivation with known uncertainty. And again, that fits statistical good practices. We stack up a bunch of data. This is just a data example. We go down to this block scale. We have a second stage sample. We have we do training data. And in the end, we stack up Sentinel-2 data, Landsat. Just to show you that we work with satellite data, I guess. And we map the soy, right? This is a very precise reference for this particular landscape. And we can use this to extrapolate and get our area for the continent or Brazil or Argentina or wherever. I like this slide because it shows you that when we stratify using antecedent years, our algorithm for mapping, we get very homogeneous populations by the previous year. So our high stratum is really a lot of soybean, and our mediums is okay, and our low is low. So it's kind of like a first order validation of the signal. And then we can extrapolate and say 350,000 square kilometers of soybean plus or minus 6,000, low coefficient of variation, and do this for all soy landscapes. Do it in the US, do it in Brazil, do it in Argentina, we're looking at China. That was the starting point for this slide deck, was the uncertainty in China for corn, and the same thing goes for soybean. And it feeds back to Joe's point of kind of reducing uncertainty and working on low latency. And then we can take these maps and create a final end-of-year map. So Shapo and Song, our group, is working on the 2019 map, and we're going to deliver that this month. So it's not near real time. They've already harvested, but have this field-based estimate that could be in the January, February timeframe. Refine that through April, May, and then make a final map in June. Just keep going. So try to kind of make this operationally practicable. Key thing is how these places are changing. So when we look at soybean in South America, we have a wonderful archive, and Inbal mentioned the need for long-term records and the implications for sustainability, effectiveness of policies such as the soy moratorium, moving soy out of the rainforest. So when we track these dynamics in the context of markets, but also in the context of environmental impacts, we can start looking at growth of soybean in Mato Grosso, and how this was very, very intensive up through 2004 and 5. The soy moratorium moved new soy out to the Cerrado. So Mato Piba became a core area for soy expansion in Brazil. Same thing in Argentina, where the Chaco is the big site of soy expansion. So again, building really consistent time series of evolution of crops and landscapes, and adding value to their use beyond just markets. And we compare this with USDA data, and again, trying to not be disruptive, but to try and see how we correlate well with official data. But this method can be used in different contexts outside of the particular national efforts. So this is an example of the same method applied across the U.S. and across North America. We've done this for four years now. The same method. These estimates represent almost 90% of soy production. We had China, we had India, we're low 90s to 95%. And it's the same method, same data sets. So it's this is kind of again a strength of remote sensing, and the signal is synoptic, and we can exploit it in such a way that we create kind of internally consistent records of agricultural production. You can read that if you like, John. Thanks.
To invite our next speaker, Esteban Copati. He's an engineer, agronomist, and heads the agricultural estimation department at the Buenos Aires Grain Exchange.
Good morning, everybody. First of all, I would like to thank you for inviting us to participate in this panel. I am here representing the Buenos Aires Grain Exchange. The Grain Exchange is a non-profit institution founded in 1854. It's the oldest commercial institution in Argentina. The main characteristic of the composition of our board of directors is that half of them represent the demand side of the market, and the other side represents the supply side. This particular composition ensures the neutrality and the unbias of our reports. I am the head of the Agriculture Estimate Department, and since 2000 season, we have published planted area and production estimates for crops that are traded in the local and in the international markets, such as soybean, corn, wheat, and barley. Argentina is one of the, as you may know, Argentina is one of the key players in world crop production. And every Thursday at 3 p.m. local time, we release a free weekly updated report to the market. Since 2000 season, we have been tracking the development of many key variables and on a national or regional scale. Our data has an impact, not only in the news, in the local news, but also in the international press. And it helps to the making decision process of market players. Most of our work is focused on data collection by doing crop tours or telephone service. During all this time, we have done more than 200 crop tours. We go to the field to take ground data, and if the crop tour gets too moving, we can survey each region from the air too. And now, thanks to the consortium, we are studying each region from the space. Having said that, I'm here to briefly talk about our experience by using remote sensing for measuring crop production in Argentina, and how the consortium has helped us to improve our work. In 2015, we started to work with GIS software and Earth observation techniques, and we immediately realized the potential of these tools. Most of the variables we study every week can be used to calibrate satellite imagery process. We created our own winter crop maps by working with Landsat images. And we started to share these maps with people, with specialists from Maryland University, who help us to improve our processes and to evaluate the accuracy of our maps. Winter crop maps in Argentina, more than 90% of the winter crop planted area is occupied by wheat and barley. And we have reached high accuracy, especially in a large scale, especially in key wheat and barley regions. The university put us in contact with several experts that were also studying what was going on in Argentina. In 2017, we joined Matt Hansen soybean projects, and we collaborated with him by collecting ground data. But we also collaborated with Service Capum and Belém France in their studies of winter crops in Argentina, by sharing ground data, crops calendars, and harvested yield at the county level. In the same way, Sergi gave us 17 years of low-resolution winter crop maps at national scale. His work captures the negative impact of the implementing poorly thought-out policies in Argentina. From 2008 until 2015, our wheat and corn were affected by export taxes and export quotas. And as you can see in these maps, our planted area was plummeted during that period, because these measures affected also the planting decision of our farmers. And some of these maps were shown by our national news. At the same time, after a couple of years making our own high-resolution winter crop maps, we started to overlap them in order to identify possible mistakes or errors. And we realized that we could easily track crop rotation of winter crops. Crop rotation is a key variable in non-tillage production system. And in Argentina, more than 90% of the crop area is cultivated by non-tillage management. So, in the near future, we will be able to understand the rotation among summer and winter crops, and in a time series, to objectively assess how sustainable Argentine crops production is. In 2017, we were invited to join NASA Harvest Consortium, and last year we attended its first workshop. in Bearsville. This was a key opportunity to meet with colleagues that have similar goals. We met colleagues from Boston University that were studying what was going on in Argentina among other regions in South America, and we began to collaborate with them by sharing large amounts of regional data, 4 years of ground truth, and crop calendars at regional and national scale. As a result of this first interaction, we already have 4 years of field boundaries data in shapefiles, and the result of their work will also contribute to the improvement of our own knowledge of our own agricultural region. Every time we join this kind of project, we realize that there are a lot of experts on remote sensing techniques who are able to run complex methodology, to process large amounts of data, to process large amount of data from different sensors, to identify crops with extremely high precision, or to map climate variable events such as flood or frost. But how many can understand the difference between registering a frost during a vegetative or reproductive stage of a crop? How many understand break-even years and can to predict how much of the crop mapping area will be harvested or not? In the same way, we, the agronomists, we can't process large amount of data. We don't know how to work with active sensors. We don't understand phytoprogramming. For that reason, I'd like to say that we have established win-win relationship with the consortium. The consortium trained us on how to study different key variables at large scale. Last January, we received a visit from Mike Hamber. Mike Hamber is senior faculty specialist from the University of Maryland, who taught us how to map soil moisture, floods, and DBI, among other key variables. And now we can cross-reference these studies with phenological stage of crops in order to better understand if floods or drought could affect yields or not, as well to understand if these negative factors are affecting key productive regions or just marginal areas. And this is thanks to the power of mapping data that allow us to significantly improve our understanding of what is going on at the field level. With all this kind of analysis, and now we can objectively explain to market players whether or not the climate anomaly will affect crop production. As I said before, we started to work with Earth observation techniques in 2015, but between 2015 and 2018, it took us an average of 30 weeks to search, download, clean, and process satellite images for mapping winter crops. The consortium has been a strategic partner on this area. And thanks to my exchanges, this will be the first year we will run our winter crop methodology in Google Earth Engine, combining Landsat and Sentinel-2 images. Accessing large-scale results in a matter of minutes instead of weeks, increasing our productivity exponentially. And this will represent a significant improvement not only for our work, but it will also represent a significant improvement for those that have to make decisions using the information we release every week. This year, we will be able to make planted area correction a month earlier than the previous season, improving the accuracy of our data during the ongoing season rather than at the end. During all these years, we've strengthened our relationship with the different members of the consortium, establishing win-win relationship, providing information for conducting research and receiving training from experts that push the frontiers of these technologies. After all these positive things, and to conclude, let me tell you about the challenges we have had. So far, we have improved the methodology for making winter crop planted area estimates, and at the end of last year, Matt sent us the result of his soil mass, but so far we haven't objectively studied our corn planted area, the second largest crop in our country, and Argentina is the third largest exporter of this crop. On the other hand, soybean and corn account for more than 70% of our total crop area, and we are still far from time to confirm or correct the planted area estimates within the season, when the decision maker from the private and public sector mostly need the information. We can adjust under or overestimation of planted area and its production once the campaign is over. And that helps us to improve the accuracy of our numbers. But we cannot undo bad decisions made by market players due to the lack of information at critical moment. We hope that working together, we will obtain objective information earlier during the season. Before finishing, we prepare a short video that we would like to share with you.
Founded in 1954, the Buenos Aires Grain Exchange has been a pillar of the institutional framework that has allowed for the development of the Argentinian agricultural sector. Among its goals is to provide high-quality public information, to promote market transparency and improve decision-making throughout the entire value chain, reducing price volatility. One of the most important variables to this objective is the estimation for crop production and crop condition that we publish every Thursday in our weekly report.
The grain markets have a particular condition in terms of supply, that is the uncontrollable variation of the production all over the world. If bolsa and cereality have the possibility to precise in a timely manner the level of production of Argentina, probably we'll have in our hands the best level of income to manage this risk, the prices that we see all the time in our local markets.
Crop estimation is one of the main issues in our markets, the agri-commodities. Because of that, all the efforts that you can do in this kind of business to get accurate figures is very rewarding. Having accurate data is not only important for the market, it's important for planning, it's important for budget, for the government.
It's really important to have a private organization such as in La Bolsa, to have good, trustworthy, reliable statistics, so be able to compare with the government. Would be very interested in having the latest technology applied to these sort of statistics, especially in Argentina, which is so big, and the area covered is so many different crops and different latitude.
Our market participants take into account the information provided by the grain exchange when taking a position in the market. New technologies will provide greater objectivity and precision to estimates. The reports of the grain exchange are essential for price discovery, and having a futures market and good information on production helps reduce volatility in the industry.
The consortium will allow us to overcome our limitations and work with technicians worldwide who are on the cutting edge on these topics. Therefore, we have great expectations for what we can achieve together.
Switch gears a little bit and go into a discussion of the panel. And what we tried to do on the first part is give a little bit of an overview from the perspective of markets and policy, some of the current state of the science, and then a stakeholder and end user perspective and how they're able to adapt and uptake this type of technology. I'd like to now introduce our panelists. Our first one is going to be remote through, so we'll just hear his voice, but I'd like to introduce Abdolreza Abbassian. He's a senior economist at the Food and Agriculture Organization of the United Nations. He's leading the FAO short-term outlook team and is responsible for market research and analysis related to major agricultural commodities. He was appointed secretary of the AMIS initiative, which you've heard a lot about, since 2011, and he manages the AMIS activities, including the monthly publication of the AMIS Market Monitor. So, Abby, it's been 8 years since both AMIS and GEOGLAM were launched under the G20. Could you tell us a little bit about the AMIS experience so far in terms of utilizing satellite-derived information, and what AMIS's view is on this whole area, and maybe some sense of how successful this collaboration has been for you?
Sure. Well, first of all, thank you for the invitation. Great to see all the friends up there on the podium. Mm-hmm. And to answer your question, 8 years, we are 8 years older, all of us, I think. We all started it together. And I think it doesn't need much of an introduction. There you have all the AMIS people sitting there, Arnaud, Joe, yourself, Seth. So I wouldn't bore you with the history lesson on that. But I must say it has been a very interesting experience for all of us involved since the beginning. It all started as sort of like an unknown process. We didn't know where it's going to end and how long it's going to take. And throughout this travel, let's say, we all learned one way or another the best ways forward. And one of which has been a collaboration with GEOGLAM, and I guess many people who are in the audience today, which come from the field of remote sensing. It was not one of the very early things that we had in mind when AMIS was more or less on its own, set up by P20 for the work. But it naturally became a very strong component of the work. And if you want, I can elaborate a little bit on that. The point to make here is that I take it back a little bit to just before AMIS in September 2010, we had an extraordinary meeting here in Rome. It was right aftermath of the drought in Russia and the big price spike. It's clear that the peak of 2007, 2008 is going to be quite a problem for the global food markets. And in that meeting, some 100 countries came. One of the issues that at least they could agree on was we were not very good in forecasting production. And the request to FAO was how we could improve this. Anyway, I don't want to bore you with this, but what is important to hear, to keep in mind is that extraordinary meeting eventually led to the establishment of AMIS a year later. And therefore, from the very beginning, among all the other factors AMIS was supposed to into, the whole issue of making better forecasts for production was critical and had the central stage. And yet, the kind of way we looked at it probably was not up to date. Perhaps it wasn't as innovative as we would have wished so. And most of our early works, and I'm sure Joe is there, can explain those better, was more on the economic side of things, on the price side of things, on the demand situation, biofuel, this and that. But we were not so much into the input crop. How good are those numbers? Now, AMIS had this privilege of having all the major really players in the four crops that it concerns with, basically corn, soybean, and rice, as its members, plus the 10 international organizations that take part as the secretariat. So it created a very powerful group of let's call them agents, where they should, if they put their resources together, be able to come up with good assessments of the market. And this was something that kind of separated us from other initiatives, even here within FAO. And that's how it all started, and it was positive. But the whole issue of production and making product forecasts remained a little bit ambiguous. Until I think we joined hand far more strongly than initially with the GEOGLAM. And if you recall, GEOGLAM at the beginning was an action mark of the AMIS Secretariat, who joined more recently. And one difference, or one advantage that GEOGLAM had for AMIS was that you had all the national agencies that deal with remote sensing basically talking to one another and having this sort of a network that we developed over time. And we became one of the first beneficiaries of this network. And thanks to this, we managed to sit together, talk, and see how we can translate your language, your scientific language of what you do in remote sensing, into the kind of a language that other market actors would be able to understand and therefore make their decisions. And this is the sort of those pie charts. And perhaps Inbal there would be easier to explain at the right time what I mean by this. But those pie charts basically developed over a couple of months, and it would be a quick glance way for policymakers, for agents, to just look and see what the market really looks like, what growing conditions are in major countries and so forth. Now, this, if I were to reflect back, I would say this was perhaps one of the more important things we did. It's not so big. It's not something that would be at par with what NASA does, obviously. But for our type work, it was actually quite a breakthrough. And it set the path for more collaboration, more thinking, more working. And this has taken us to today. So today we have a system, a network, both within AMIS and GEOGLAM. We meet, as you know, very regularly. We talk to one another. We produce a report together every month. Olympus Market Monitor, and you guys went ahead actually GEOGLAM and produced a report for the rest of the world, which is even more important, especially for vulnerable countries. The way I see now is that we do need some innovative thinking ahead in this process to try to get more out of what you can offer in terms of the satellite and remote sensing technology. And I think this is where I hope the discussions that you have in your, what it seems, extremely successful meeting with the two, in terms of what's the roadmap you have for the next couple of years in order to use the facilities, the technology, and the network that is now available to enhance it.
Thanks. Thanks very much, Abby. Sure, and I think what we're hoping actually to hear from many of you on the stage who are actually very much coming from the markets and economic side is what are the needs that can help to guide the products that we develop, so we avoid the mistakes of the past where we're developing great products that we think in a vacuum of research and then wondering why they're not being used. Maybe a quick other question for you, Abby, is and I think I'll follow up then with Seth as well, is given the recent increase in volatility in markets at the moment, in large part due to uncertainty surrounding the U.S. crop, and I think we've seen some unprecedented month-on-month cuts to the U.S. corn forecasts, both on the USDA side and on the ANDIS side, as well as other organizations in IGC as well. What types of information do you think could be provided that would help to reduce this uncertainty in markets, and from your understanding, working with us for so long in terms of remote sensing side?
Right. Well, this is certainly a good question, a very timely one. I'm not so sure I have the full answer for it. It is certainly a very exceptional period, definitely in the US and what's happening with the corn. And it's been an engaged situation for people who are following the market for now some weeks. I turn this question a bit around, and this is, I mean, I'm just thinking loud on this because this really has been a concern. It's happening in a country with the most advanced information system, both in terms of satellite military information and in terms of a mechanism to collect information through surveys and all kinds of analysis. So it's not happening in any country. And therefore, if we cannot use the technology that's available in these days in a country like US for this type of work, I just wonder how one can really go about and promote it in other places. And this doesn't need to be negative. I think it is very positive. I was just before getting started, I was going through my tweets and all these images coming out showing comparing now compared to last month, compared to last year. This is how corn looked like it then and how it looks like now. I think all this information are quite useful. What I'm not so sure is how the information could reach me not from 10 or 20, 30 different observers, but from a place that I can fully trust that they have done their homework, they have looked at all these different aspects, and they were not just giving me any information in order to influence my decision and that could eventually influence the market in a way that probably is not the right thing to do. So I think this is happening here, and I hope that through the initiative of Harvest will eventually happen, is some sort of validation to what we see through satellite imagery that can be a source of objective information for the rest of the world to take on, rather than looking at individual bits and pieces of this information. And I think such an experiment would be most valuable if it could be started or initiated in an advanced place like in the US.
Thanks very much, Abby. I think we're doing a lot of thinking, and I think this year, and as do always extreme event years, new challenges come up, and we try to think through, well, how could we have addressed that, or how in the future, when that comes again, are there information products that can come from private sector, from public sector, from research to support those needs? I think what I'll do is introduce actually the rest of the panel, and then come back to you as well, Abby, on that. And so, Dr. Seth Meyer is the chairman of the World Agricultural Outlook Board at the USDA, publishing the monthly World Agricultural Supply and Demand Estimates, as all of you know, WASDE, which are closely watched by agricultural markets around the world. Before joining USDA, he was part of the UNFAO Global Perspective Study Unit and a researcher and faculty at the University of Missouri. Arnaud Petit was appointed the executive director of the International Grain Council back in 2018. And prior to that, he was the director for commodity and trade at the European Farmers and Agri Cooperatives in Cooperatives Union. And finally, Ian Jarvis, he's the director of the Global Agricultural Monitoring Initiative, GEOGLAM, which we've already heard quite a lot about. Prior to being the director of GEOGLAM, he had 25 years of experience with Agriculture Agri-Food Canada, and had served as a director of Agroclimatic, Geomatics and Earth Observations Division within Agriculture Agri-Food Canada. So with that, I'll proceed a little bit with some questions, and one for you, Seth. And USDA clearly has long recognized the importance and huge potential of Earth observations for provision of agricultural monitoring, and going back into the Lacey days, as we've heard. What role do satellite data play in the current USDA forecasts, and how do you see this evolving in the future, and in particular in the context of what we've just been talking about and hearing from Abby as well, and these kinds of events in a year like this year?
So for satellite imagery, I guess I'd contrast that in the United States we have NAS, and we were talking earlier about, well, we can get within 3 to 5% in yields. That's too wide for us in the United States, so we have NAS in terms of our domestic market. We don't have that everywhere else in the world. So we rely, and by we, I'm not talking just about the World Board. We're a collaborative agency, so we bring groups from all around USDA, and in particular, in this case, our folks from FAS. So we rely heavily on satellite imagery for our analysis around the world. But we combine it with meteorology. We have 5 specialists in crop development. We have folks on the ground, and all of those things we use together. So we're using satellite imagery as a tool. Domestically, the folks at NAS do use satellite imagery, but of course their gold standard is going out into the field and measuring. But that's expensive, and there are gaps between when they're measuring, they're doing this on a monthly basis when the crop is far enough along in development. And so from a commercial standpoint, there is perhaps some utility for satellite imagery either earlier in the season with an understanding that it's going to remain incredibly uncertain, and then perhaps between reports as the season goes on. So that's how we use satellite imagery. It's only going to get technology, is only going to get better.
So in that case, how do you see it going on in the future, given the advances?
So I think that, again, there's always going to be pressure on NAS to justify its expenditures on field level surveys. I would say I'm not willing to give that up. We need that for our domestic market. I think what it will do in the future is we can use it for special applications in the United States. So when you talk about flooded acreage this year in terms of, or prevent plant, we have a plan, it's a complicated discussion, but you could use that to talk about when you have flooded. There was a discussion about grain silos maybe lost to flooding. You could actually do some of this tracking with satellite imagery. But on a foreign scale, Joe showed the fact that yields and production and area within Russia is quite uncertain for wheat. They're the world's #1 wheat exporter, and therefore nailing their production better will reduce fluctuations in the market for wheat prices. So for us, I think it will help us with large countries where we don't have as much information to improve market function.
Great, thanks. So then moving on to and IGC is an intergovernmental organization focused on furthering international cooperation in grain, trade, and market transparency, very much similar in many ways to the objective of ANIS. From your perspective, what are some key information needs and opportunities that remote sensing analytics can support for furthering market growth and trade?
So, first of all, so we follow 16 commodities, and we are on track to add pulses in our portfolio activities. So you see our having distinction in the mapping and cropping area is very important for us because it would help really to improve our market analysis. And I will not come back on the issue of the timely, accurate information. It has been well described by Joe, but I would like to add 2 main aspects. First of all, is a learning curve. All this remote sensing is adding. Because we have seen from the last 3 seasons, we have new events. and it's all the time very difficult to interpret the impact on production. And thanks to the remote sensing and big data, now we have more advanced analysis on impact on these big events. This year it was a corn in US. We had in India less rainfall. What has been the impact, or in EU with a low luminosity and wheat production. So I think it's very important to have this learning curve process, I would say, in mind. And the second point I would like to add is also what Seth is starting to say is that we have a new country entering in production, and where we have not necessarily a full information, or I would say available information. And here also the remote sensing system can help us talk about Russia, or I would say Eurasia area. If we want to be more wide, where definitively we need more information. And I would say for the future also in Sub-Saharan Africa, because we see some new development in production, and rice, for example, and as a staple food, that's something we really need to improve, I would say, to have more market information. So I would say it's what we are waiting for. Thank you.
Okay. Thank you. And so Ian, and I think many of you might have known Ian in his previous role when he was within Agriculture, Agri-Food Canada, and at that point you were the division director leading the Earth Observation Space Monitoring Unit. And in that role you were able, and I think probably it's correct to say that partly through these partnerships that we had engaged between AMIS and GEOGLAM, where the AMIS side brought the economics unit from Agriculture Food Canada, and you were very much from the remote sensing side. But you were able at the national level to forge a very strong relationship with the economics division. And that ultimately resulted in the replacement of a key survey for Canada, which is your September survey. And if you could tell us a little bit about the evolution of that decision and how that has played out for Canada.
Okay, well, for reasons that were well articulated here, yield forecasting is an important tool. So we were working on the science for quite some years, and it was in pretty good shape. But as I often say, the science is easy, the management working with people is sometimes challenging. And this is a very good example of that, because the statistical agency for Canada, StatsCan, were responsible for the official numbers. So it actually took us over a decade of starting to work with them and getting more familiar between the communities to actually have this yield forecaster launched. But when it was launched, it was so tremendously successful because it saves millions of dollars a year in survey costs. It produces information which is more rigorous, arguably, than what had been done previously. And from a political standpoint, it reduced the survey burden. And that was very important in Canada at the time. So building on that success since then, I was talking to Champagne, who's in the audience today from Agriculture Canada. They're now piloting a July replacement, so it's progressing. Recently, staff at Agriculture and Agri-Food Canada have been given deemed employee status within StatsCan, so they can actually go within the firewall of the statistics agency, bring the Earth observation data there, and work at a very high resolution level on new questions that we need answered, things like early season crop area and so on. And once we have early season crop area along with our model yield projection, well, we have the holy grail, which is we start to get a better understanding of production earlier in the season, and I think that's some of the things we've heard up here. This is kind of what we're all shooting for.
Right. And then, I guess, stepping into your GeoGlam role, I think you've advocated quite strongly for the need to continue to improve those estimates and those early estimates, and also very much encouraging and facilitating really that partnership. And I think what we see on this stage today is actually quite remarkable, because we've got really senior economists and connected very much to the policy side, and senior researchers in the Earth observation side. And I think part of the challenge of prior why we weren't seeing the impact in the uptake that we wanted was there wasn't that communication. And today I think we all know each other quite well, working for several years and really learning each other's languages, learning where is it that we each fit in with each other's program. And still obviously a huge amount of work to do, but a lot of that work is actually understanding partnerships and communicating with each other. And so as within GeoGlam, and recognizing, Harvest is NASA's contribution to GEOGLAM. What role would you see for Harvest and its contributors going into the future?
I'm really glad you asked me that, because it's impossible to underplay the real impact that Harvest has had on GEOGLAM. Particularly, NASA was brilliant in creating a program that had a 5-year funding. 5 years is very long in a government context. That brought stability, and the excellent work that's happening around the crop monitors, both for markets and food security, are critical. And so that stability has allowed us as a community to look beyond where we are now, and now we're looking at defining essential agricultural variables. It came out a bit from the talks up here, but there's a real desire from the market side and the food security side to have more quantitative information around this. This is required for markets, but also things like sustainable development goals and climate change and so on, where we really need to be more quantitative and look at things not just within a growing season, but look at what's happening over the longer term. So I think a lot of the research, some of the work that Matt showed and some of the work that showed up yesterday in the market event we had in the morning, that research is right on track to really contribute to these. And as we all evolve as a community, Harvest is well positioned to continue to help us move forward, and really looking forward with such great success in the first part of Harvest to see what comes next. It's very exciting.
So one question maybe to all of you, and I think listening to kind of Ian and where some of the priorities on the remote sensing side is, and I think we should always be very careful in thinking about what we think your priorities are. I'd like to ask you, what are some of the information gaps that you think either the research community, private sector, or other organizations can help to support and should be focusing really their efforts on within the remote sensing community? And anybody who'd like to answer that?
If I may, I would say so. We can always ask more, but maybe also from our side, we need also maybe to improve our information network. So I would say production and forecasting, or maybe better than what we can do in terms of forecast price, I would say, on the market. So this is why I think, first of all, maybe we have also to improve our collection of data sometimes. It's very difficult today to have for several regions of the world price at destinations. We can do for price exports, but price at destination is very complicated. So we are close to, we are working on it to have a better information of price of destination. And I do believe that it would be interesting to cross your information in terms of forecast yield and production, and also our information on trade. And that means then we can assess better climate event which impact on trade patterns. But I would say here we have as an economic community also to improve, I would say, our information, but definitively that's something that would be very interesting to develop further. And another point I would say, but here I know that I'm really going outside the boundaries of what is possible today. When we do our supply and demand, I would say we add different type of grains. When we talk about soybean, we add the soybean from Argentina, Brazil, and US, but not necessarily the same content of good protein, vegetable protein. So that means we talk about raw material, but not necessarily the nutritional value. I know we are not yet there in technology, but that's something would be very interesting if we can move forward, because then we don't touch only the raw material, that we can go further in terms of markets, premiums and quality, but also the food security aspect. So that's also another topic I would say which may be very interesting to develop for the future.
We are out of time. Okay, I'm getting a message over.
I'll give the panelists a comment, but then please.
Okay, so if anybody else wanted to have a quick comment on that or not. I mean, I think for us, and I think we have within Harvest recognized that we have to establish these strong partnerships, and they've got to be long term and continue to work both with the operational agencies, understand what the priorities are, and how we can really help and support to forge these partnerships and continue to move forward. And part of our role is really facilitating also partnerships, whether they're internally across within countries and within different organizations, or really across and internationally. Thank you very much all for participating in this panel, and